Hello and welcome back. Today let's solve Leetcode 215 k largest element in an array. So the problem is given an array of nums and an integer k. So our task is return the k largest element in the array. So the k largest element in the sorted order, not the k distinct element. So I think the problem is very straightforward, right? We will need to find the k largest element, not the k distinct largest element. It means, for example, for this array, and with k is 2, so we will our answer will be 5. Why? Because 5 is the second largest integer in this array. Well, for example, if we sort this array in ascending order, we will receive 1, 2, 3, 4, 5, and 6, right? So that the second largest element will be 5. Okay, so the knife approach for this problem is we can think about sorting, right? We can sort the input array in the ascending order, and then we can easily get the kth element. That's exactly the kth largest element. But for this problem, it requires us not using any sorting algorithms. Okay, okay, and if if we don't use sorting algorithms, we will have uh, another algorithm that's more efficient, that will run a little bit faster than the sorting algorithm. Because if we use sorting algorithm, so our time complexity will be out of n log n, right? Okay, so let's see if we have another solution for this problem. So let's see. Well, I for this problem, we can apply the technique called quick select. Quick select. Oh, let's zoom it. Okay, so the quick select algorithms can help us to find the kth smallest element in the array, right? So the idea of quick select is quite similar to a very famous algorithm, uh, a very famous sorting algorithm called quick sort. Okay, so let's check for the idea later on. So but anyway, for the quick select, we can easily to find the k smallest element in the array. But for this problem, we will need to find the k largest element in the array. Okay, so how to apply the quick select to find the k largest element in the array? Okay, and well, it's a very simple to have a very simple convert, right? Because k's largest element will be equal to, it is the length minus k, that is the length minus k smallest element, right? So to find to find the k's largest element, we will need to find the length minus k smallest element, and to find the length minus k smallest element, we will apply the quick select. to find this smallest element, right? Okay, so that is the idea to apply the quick select to find the case largest element. So please okay, and again please note that the case largest element will be equals to the length minus case smallest element. Okay, okay, so let's apply this into our problem. So we will need to find the fourth largest element in this array, right? So it means we will need to find the the length minus k. So we have k is 4, right? K is 4, and the length of this array, how many? 2, 4, 6, 8, and 9. We have 9. So the actual the actual element, the actual smallest element that we will need to find is 5, right? So so instead of finding the fourth the fourth largest element in this array, we will find the fifth we will find the fifth smallest element in this array. That will exactly the answer for the problem, right? Okay, so let's apply. Okay, so for example, let's uh, check for the idea of the quick select algorithm. Okay, so for the quick select algorithm, we will need to keep track for three pointers. The first pointer is the pivot pointer. Right. For the pivot pointer, you can choose randomly any index in this array. But for me, I usually choose the first index as the pivot. Okay, so for example, this is our pivot, right? And then we will keep track for two other variables. The first is the left pointer, and another one is the right pointer, right? So our intention is we will try to shift all elements that are smaller than the pivot to its left to its left, and we will try to shift all the elements that uh, of the element that are larger than the pivot to its right. Okay, okay, so to do that, uh, first we will next need to check for the array from the left and right first. Okay, okay, so first we will need to check for some condition. Okay, so we will compare the nums at left with the nums at pivot, right? If the nums at left is less than the nums at pivot, or maybe less than or equal, right, num as pivot, so what we do, if the nums as left is less than the num as pivot, for example this case. Okay, so in this case we don't need to do anything. We only need to increment the left pointer, right? So if this condition is satisfied, we only need to increase the left pointer. Okay, and if nums at right is greater than or equals to the nums at pivot, so what we do, for example, uh, the nums at right now is 6, that is greater than the nums at pivot, right? So what we do, we only need to uh, shift the right pointer. We only need to shift the right pointer. uh, we will decrease the right pointer, right? Okay. So if this condition is satisfied, we decrease the right pointer, right? And for other case, if nums at left is greater than nums at pivot and nums at right less than the nums at pivot. Okay, so what we do for this case? Okay, so uh, for example, if the nums at left is greater than the num at the pivot, for example this case, right? So now we have left is here. Okay, so left is 4, that is greater than 3, right? 4 is greater than 3, and right. Okay, so let's do step by step, right? Okay, so we have left now is 3, that is greater than less than or equal to the pivot. So we will need to shift left to the next position. Okay, and for the right, 5 is greater than 3, right? So it means the numbers at right position is greater than the number at the pivot position, so we will move the right pointer to the previous position, right? And then same, 1 is less than 3. Okay, so move left to the next position. 5 is greater than 5. 5 is greater than 3. Okay, move to the previous position, right? And then same, right? Uh, we have 2 less than 3. We will move the left here. 4 greater than 3, move the right here, right? Okay, so now we notice that the right pointer is now less than the left pointer. We will break out from this. We will stop doing. We will stop checking for this condition, right? We will uh, keep checking for this condition while left is less than or equals to right. And then what we do next, right? Because our intention is we will try to shift all the smaller elements to the left of the pivot. So it means here we notice that the correct position of the pivot, it must be in the right pointer, right? It must be in the right pointer. What we do now, we will need to swap. We will need to swap the element at the pointer index with the element at the right index, right? We will need to swap it. So for example, now this one is the first element is now 2, and for this element it will be 3, right? It will be 3. Okay, and now we notice that the right, okay, the pivot, the element at the pivot is now in the correct position, right? Now in the correct position. and then we will check it with the k. We'll check the right with the k. Okay, check the right with the k. So what happens here? Okay, if the case is, oh sorry, if the case is greater than the right, it means it means it means the case smallest element, the case smallest element will always appear in the right part of the pivot, right, will appear in the right part of the pivot, because the pivot we know that is already in the correct position, right, it already in the correct position. But if we want to find the element that is greater than its pivot, so will need to find we will need to find from the the we will need to find from the right the right rate of the pivot, the right part. Okay, and else we will need to check for the left part, right? Mm. Okay, so okay, so this is so, and we will uh, check the right part of L. Okay, okay, and else we will check left part of right. Okay, so I think in this example there will be no example for this case, right? But if we got this case, what we do is we will try to swap the the, the numbers at the left pointer with the numbers at the right pointer, and finally after we out from the while loop, what we do, we will need to swap the pivot, the numbers at the pivot with the number as the right pointer, right? Okay, so that's all for the idea of the quick select. Okay, so let's dive into the implementation. Okay, so because this problem is warranty that we will always have the answer, because the case is greater than or equals to 1 and less than or equals to nums dot length. Okay, so I think we don't need to check for any S case for this problem. We can deep dive into the solutions. Okay. Okay, so first of all, let's implement the quick select algorithm, right? In quick select, we have parameters, the nums, we have parameter from left. Okay, if we go in start, right, in n and in Kate. Okay, okay, so as we warranty that we will always have the answer, so let's use the while true loop. Okay, and then we will select a pivot, the pivot that is the start index, right? I will always choose I will choose the first index as the pivot, and we have the left pointer is starting from the start plus 1, and the right index is the end index. Okay, so y left index less than or equal to the right index. So what we do, okay, we will check for this condition, right? Okay, check for this condition. Okay, if nums as left less than or equal to nums at pivot, okay, this case we will need to increase the left pointer. If nums at right greater than or equals to the nums at pivot, we will decrease the right pointer, right? And if the nums at left pointer is greater than the nums at pivot, and the nums at right is less than the nums at pivot, we will swap the nums at the left and the right. Okay, so when we out from this while loop, we will need to swap the nums at the pivot with the nums at the right index, right? And now we will compare the right with the k. If right is equals to k, so we know that the nums at k is the answer, right? Because uh, because the right now is the nums at the right now is warranty that stand in the correct position of the array. So if the right is equals to k, so our answer is the nums at k. Okay, so if right is less than k, so what we do, if the right is less than k, so we will need to check uh, okay, so if the right is less than k, we will need to check for the right part, right? We need to check for the right part. It means we will need to update the start index. It equals to uh, the left plus 1, right? Else we will need to check for the left part of the right. It means we will update the right to left minus 1, right? Okay, so okay, and now let's declare a method for the swap. Okay, we need to swap the position I with the position j in the array, and then what we do, we will need to declare a temp variable that assigns to array at I, and array at I is equal to array at j, and array at j equals to temp. Okay, so for the main methods, we only need to call the quick select algorithm with the array is num start index is 0 and index is num dot length minus 1 and the k. Okay, so well, for the k, we our intention is 5, the k largest element, right? But the quick select algorithm that only can help us to find the case smallest element. Okay, and then we will need to convert, uh, we 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 will need to change it, we need to change it from length minus case, because we are finding the case largest, that exactly is the length minus case smallest element. Okay, minus k. Okay, so that's all for the implementation. Let's try. Oh, we have time limit exceeded. Okay, so let's check. uh, Time limit exceeded. What's wrong here? I think it's because uh, okay, if the right is less than k, if the right is less than k, we will check for the right part or the right part or the left part. So let's check again. Um, okay, so for the right next is now here is 3. Okay, 3, and the position is 0, 1, 2, 3, and 4. Right, the index is 4, 0, 1, 2, 3, and 4, but we will need to find the fifth largest, fifth largest. Okay, so we will update the start. The start will be equal to start equal to the left. uh, should be the start equal to the left, not the left plus 1. Okay, again, runtime error. uh, okay, and how about the right? Okay, for example, if we no, my bad, because here we are comparing the index, okay, so for this one is uh, if we will check for the right part, if the right is greater than the kate, not less than, because we are comparing the index, not comparing the value. Okay, so let's update again. Okay, still some limit exceeded. Hmm. Okay, I think I figured it out. Because okay, so now here we will check for the right part of the right index, right? So we only need to update the start and the end index, depend on the right position, not depend on the left position. So that's my bad. Um, so let's update right. Okay, and if the right is less than k, is right plus 1, else right minus 1. Okay, again. Oh, so now it looks good. Okay, so let's try to submit. Okay, accept.